So we have specified an econometric model where household per person food consumption expenditure is a linear function of a household income. And we collect data. And we can estimate this econometric model by what is called ordinary least square estimator. Now we're going to implement this OLS regression in R. I already have a code here, so I'm going to go through the codes. So line 5, I'm going to remove everything from the environment here, just in case not to confuse with other object. Then I'm going to set working directory to folder temp data under drive D. Then the data are stored in this file in CSV format. So I'm going to ask R to read data, and I alert R that there's a header. The CSV has the first line is the name of the variables, and then give this object name SL data. So let's run the code. So now in the environment, I have a data object called SLR data, which has 40 observations, 2 variables in it. Let's double click it. So that's the data. Food consumption, income, first observations, income weekly household income is $3,690. Okay, bear in mind the unit of these variables. For food expenditure is $115.22, so the unit is dollar. That's for the first household, second, third, so on and so forth. Altogether we have 40 households. Okay, let's produce a summary statistics of the data of the 2 variables. So summary SLR data. So here's the result. The average mean income, the sample mean income is $19,600 weekly. Average food expenditure in the sample is $283.6, and we can have maximum, minimum, medium, so on and so forth. We can actually let's plot a scatter plot here. So, okay, in my plot here, on the horizontal axis is food expenditure, vertical axis income. So I wanted to switch the axis. So this I want this to be the income, and the vertical axis to be food expenditure. So let's run the code. There you go. And by looking at this scatter plot, we can see that there's a positive relationship between income and the food consumption expenditure. Okay, we now want to run a regression of y against x. Y, the dependent variable, is food expenditure in our current case. X, the exponential variable, is income, and with that R knows that the data is stored in here. So LM is the inbuilt command that conduct ordinary least squares estimations. If you want to know more about LM, you can input question mark LM, then you can go through all this, and we will use LM later on as well. That's a linear model. That stands for linear model. So run the linear model, output the results into an object called model 1, and let's summarize this one and output results into an object called s.model1 and show the s.model1. So let's run the regression. Select the codes and run. So now we create, in the environment we see there are two additional objects now. One is model 1, which has a list of 12 elements in it that contains the regression results. And s.model1 is a summary of this model. So that's the output that we see that. And most important quantity that of interest to us is B1 and B2, estimate of beta 1 and beta 2. So intercept here is the point estimate of the beta 1, which is 83.416. Intercept the coefficient of income is the estimate of beta 2, which is 10.210 here. And we can check other statistics like t value, t stat, p value, so on and so forth.